name is Abunijem. I work for AWS. I'm based in California. And I can confirm the comment that was made earlier that electricity is very expensive in California. So this is true. We don't look forward to the electric bill every month. Riyadh, for me, is like a home. I grew up in Riyadh. I love to come here. And I'm very, very excited that Saudi Arabia is starting this initiative focusing on semiconductor. Semiconductor is no longer a luxury. It's a national security. It's a must-have. Every country in the world is having their own initiative when it comes to semiconductor. The US has the CHIP Act. They invested a lot of money in Intel and other companies. I worked for Intel for about 12 years, part of them here in Saudi Arabia. I've been with AWS for about 7.5 years, focusing on semiconductor. Last year, I ran a roadshow where we visited almost every region that has concentration of semiconductor companies. Taiwan, Korea, we went to the UK and London, ARM and others, and Japan. And I'm going to summarize to you, for Saudi Arabia to be successful in the semiconductor area and industry, we need to start where the other ended, not where the other started. Going back and looking at how Intel started and what they did, and then try to replicate that will not be a great recipe. Things has changed, technology has changed. If you look at the current challenges, they're all different than the challenges that they were before. It was mentioned earlier, the high demand for chips, the supply chain complication, the going from 7 to 5 to 2 nanometers. These are complex design. They require a lot of compute power, specialized compute power. Having on-premises data centers, I know a lot of people, and this isn't, I'm giving you what I've collected hearing from customers. All the customers are telling us the same thing. They have the same pain points. So, having the same infrastructure to run every semiconductor workload is not efficient at all. Front-end design validation and back-end workloads are totally different. The memory to CPU ratio is different. Having a data center, typically you have the low common denominator for all the workloads. You're trying to run workloads on the same hardware. And nowadays, with AI, with EDA workloads, they are different. You need more customized. The one-size-fits-all does not work anymore. That's why you see a lot of the hyperscalers, at Amazon, we have our own semiconductor chips. We do our own chip design internally because this is becoming a competitive advantage. You want to have control over the ASICs, the CPU or the GPU, whatever you're designing. You want to be more efficient. You want to lower your cost. Our Graviton own in-house chip design is 40% performance better than the generic CPU, the x86 CPU. It's an ARM-based, by the way. The same thing. We have a custom chip for inferencing called Inferentia. We have a custom chip for training called Trainium. Because you have the right cache in the CPU, you have the right memory in the CPU to address those and to address the needs of the workloads. So one size fits all does not work anymore. You need to use the latest technology. When you have on-premises data centers, typically to get your ROI, you keep the data center for 5 years. At Intel, sometimes they keep them for 7 years. Nowadays, you cannot afford to run your workloads on a 5-year-old hardware. And you cannot keep updating your hardware every year. It's very, very, very expensive. NVIDIA, right now, they're releasing a new GPU almost every year. You cannot just keep updating. Once your hardware lands in your data centers, it's already outdated because you need at least 6 to 9 months to get the hardware. And with the backlog right now that we have in the industry, it will take you even longer. So you're always behind when it comes to technology. And when you buy it, you cannot just throw it away and buy the new ones. Time to market is very important for many customers. We talk to customers. If you notice, sometimes the chip design, it's delayed by a few months, by 6 months, 8 months, 9 months, and I'm going to talk about some of the reasons for those delays. It's becoming very competitive, and semiconductor companies cannot afford keep delaying their products. The lost revenue and the cost of that delay is becoming very, very high, and it costs the companies their market share. Companies are no longer living in the same space. People work globally. TSMC is manufacturing for most of the companies. So they need some infrastructure to facilitate the communication, the collaboration globally. And finally, cost optimization. You need to have the most efficient hardware to run your designs and your EDA workloads. On-premises is becoming very, very challenging, as I mentioned. It's nice to have a data center. A lot of people would love to have, we have that many CPUs. I know, for example, we're working with Intel, they have more than 5 million cores in their data centers, a lot more than that. But what kind of value does this add to your business as a semiconductor company? You are not in the business of managing data centers. You are in the business of innovating, of designing chips that will add value to the market that you are working on. Having a big data center, more efficient data center, you're dealing with the security of that data center, with the power management and many, many issues that has zero value to your business as a semiconductor company. So we have to change our mindset and the way we think about designing chips and ASICs. And we're hearing that from many of our customers, especially in the startup. In Saudi now, we're looking at starting new companies or hosting new companies here. Startup companies, they have limited funds. Taking that fund and spending millions of dollars building data centers is not the most efficient way to utilize this money. This money can be utilized in innovation, designing, in IP, and so on and so forth, instead of just having it in data centers, locked up in data centers. A lot of our customers, I've met with virtually almost all of the semiconductor, all the big names that you know. Every single one of them is looking at the cloud for some projects. We're talking actually to some companies that they are doing end-to-end chip design on the cloud. They're running them as a POC, proof of concepts, and the results are impressive, and they're looking to move more and more workloads to the cloud. I'm not saying that shut down all your data centers and move to the cloud, but you need to look at the cloud. The cloud is the most efficient for some use cases, for some workloads, and it's a serious optimizer for semiconductor and EDA workloads. These are some of the feedbacks we got. We worked with ARM. There's a public case study. ARM is one of the companies that went all in on the cloud. They were planning to shut down. So ARM is a fabless company. They were looking in becoming a data center-less company, shutting down as much data centers as they can and move them to the cloud. And I'm going to show you a slide about how efficient they became moving to the cloud. They were able to innovate faster, collaborate better, reduce the risk, and reduce the cost, even though a lot of their perception is that the cloud is more costly than on-premises. This depends, and there are more details into this. This is that's what we see in the industry. You have your data center. You have a set capacity. I'm not sure if there's a pointer here that I can use, but so you have extra workload here that's coming. You don't have enough capacity. You have engineers waiting to get capacity, hardware capacity to run their workloads, their EDA workloads. And one of the most expensive part of your EDA design is your engineers. And when they are sitting idle waiting for hardware resources, this is a very high cost for you. Now, you go and buy new hardware, provision them, It takes time for them to come or to be delivered. And when they come on board, the projects are down, so you have capacity sitting doing nothing. That's an investment with no return. And you get into that cycle back and forth, up and down, up and down. However, if you utilize the cloud, you only provision what you need. You need CPUs, you go provision, you need 100,000 CPUs, you go provision that in minutes. When you are done, you shut them down. You have a workload that you need inferencing, you need GPUs, you go provision those GPU instances, run your workload, and then you shut them down. So you're always running in an efficient way. Not only that, you can scale as high as you want. This is represent the on-premises. You have a finite capacity of hardware. You're trying to fit everything into this finite capacity. However, when it comes to the cloud, you can just scale as high as you want, reduce the time to market, and you can deliver ahead of schedule. This is a very interesting chart. A lot of people, when they talk about the total cost of ownership for data centers, hardware and infrastructure is only 10% of the cost. Only 10% of the cost. So focusing on trying to reduce and optimize only 10% of the cost is a waste of resources and waste of time. Licensing, ADA licensing are very expensive. Those who did run some ADA workloads can tell you that. Cadence and Synopsys, and it's the most expensive. Actually, I got this slide from one of the ISVs. So software licensing is very expensive. And that can also translate to running those licensing on an old hardware. That will get you even more, the cost would be even higher. And engineering cost is about 50% of your overall ADA workflow and design. What I'm trying to say is that we need to move our mindset when we talk about semiconductor from TCO to TVO, total value of ownership. TCO, you're focusing on only optimizing the 10% of your cost. You need to look at your overall value for the project. Some of our customers that used the latest technology, they saw 20% optimization of their licensing and reducing cost. Latest generation of instances that we had offered some customers 60% savings. What I'm trying to say here is that you need to look at your overall business, the value that this compute is providing for you. You need to ask yourself, if you want to attract global talent to Saudi, how soon you can get them up and running, designing chips and sending them to TSMC to manufacturing them. You need to think about the cost of the delay if your tape out is delayed. You need to think about the unutilized resources that are sitting doing nothing, either hardware or human resources. The opportunity cost when it comes to semiconductor is one of the biggest challenges that we see or heard from many of our customers. What I'm trying to say here is this slide, by the way, from ARM themselves. This is an example of the success of moving to the cloud. ARM told us that before the cloud, they were able to run or to have 15 projects in 4 years. Now they can run 25 projects at the same time in those 4 years, the same time. It's really hard to put a dollar amount on releasing chips early, right? You can put a dollar amount on the cost of the hardware. You know, we bought those servers for X million dollars, but you cannot put a dollar amount of how many chips you released in a year. It's the total value of ownership, not the total cost of ownership. This is basically the message I'm trying to deliver here to Saudi Arabia. To get ahead, we need to leapfrog the industry. We need to not to look at the past or what they did in the past. We need to look at how we can avoid the mistake that they've done, look at what they're doing now, and I can guarantee you we're talking to all the customers, the major semiconductor customers, and they are looking at the cloud in a very serious way. Some of them already in the cloud, like NXP and ARM. And we are working with, you're going to see some more case studies about some big names moving to the cloud. And I don't want to take too much from your time, and will conclude my presentation today. Thank you.